Today, this is going to be a story. The thing is that I had one question. The question is that, like, why, solar and transit, like that eclipse, like, so big. Like, why? And why, literally, solar eclipses are just like a line. Like, why? So, this is just a story about how I wondered this question and how I got the answer. And you can just apply my experiment to any other exhibition if you want. Okay? Now let's jump right on to my story first. While I was just editing this video, yeah, the rain is coming. So, okay, I was just starting to edit and rain came. Okay. This all began of while I was just reading The Scientist, and I used my guidebook as my reference, and my guidebook was present. It was actually should be an 8th standard book, and they labeled as 6th standard as it was international, and they got all the information from all the class. And while I was just studying about that, I just read about this solar eclipse. Like, I didn't know how does this work. So I was just keep wondering, and I just wondering why is it like that. Then I just got an idea. So I just took like Earth and Moon. Then I saw that experiment, and the sun was my replica. That replica of that sun was my phone. No, but I don't have no time. No, because as I was searching a little deeper, I saw these images that I showed you, but I still can do that because I need to read. So I was just keep wondering till I just okay, let's just wait. Then I did the experiment. I waited for about 4 or 5 days. Then yeah, this is how that story began from now. So first of all, I just need to say something. You will hear some rainy things, rain sounds because I want to record outside because it's cool. Well, the first thing I need to just pass this was that I need to make an earth. At that time, I made a similar earth which was never ever accurate, and a moon which was also never ever accurate. So yeah, I took my globe. I don't know how to make the replica of the moon, so I just dug up my 6th grade book, and I just need to see what's that replica. Yeah, and I just saw right there the diameter is only 1/4 that of the earth, which was good information for me because now I can just scale it with a thread, measured it, and I was happy. Okay, here's today's progress. I made the earth, not the earth, I mean the globe, and I just rip off that. And then there's the moon. I just calculated that, and I don't have the footage. But still, the only thing that I did is that I just marked 2 places right here on the globe, which is right over like in the equator. they have that marking in that equator. Like right here. Look. Right here. Like I'll align that with that rope. So that I can just see that. Because I just searched in my geography book and I just saw the diameter just means that a circle and I just cut that circle from one longitude and yeah, and I need to just measure that. Then I cut it into fourth. I just measured it correctly and it was 23, which was very, 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 very angry. Then this happened. I bring out the calculator and I divide it by 4, which is actually 23 by 4, and it gave me 5.75. Wait, sorry, 5.57, which is the diameter of this moon. The diameter of the moon. And I said a diameter is just cutting a 3D object, as I'm calling this as Earth, into its longitude, and I measured it, right? Like, how far can we see? The same thing that I did to the moon, and it worked. And this is the replica of that moon. It's white because if it's colorful and shiny, it will just glow on lunar eclipse that I've done in before, and I lost that footage. Okay, so this is the replica of the moon and this is the replica of the earth, and this is accurate because like they gave here the scale, like look here, look, like they gave a scale. So yeah, I can accurately measure this. No, don't fall. And I can accurately just do the diameter thing that I said and make the moon. So I made the moon, but now I need to have a replica of that, which is going to be difficult because I need to have the correct exact matching of the Earth's diameter thingy that I said, or I can use the moon diameter thingy. But for now, I'll use the Earth diameter thingy for calculations and stuff. Okay. So yeah, the progress and low. Well, at least we have the replica of the moon, and the one thing that I can for surely say is that very strong. Like at that time, it was like very weak. Like when I spun it like this, it just fall down for no reason. But now, this object, even if I spun it fast like a fan, it can still stick on it. I think this is a perfect tape. I don't know what I'll do, but still, I need to know the distance between Earth and the Moon, then the Earth to the Sun. I still didn't get the replica of the Sun. I'll show that later. And I need the replica of the Mars and the distance of Mars. This is getting complicated. Well, that's okay. At least we have made the No. Oh yeah. This. Well, also you'll say, why did you attach the thread? It's because if you visited Minutepyscics, you might know that the moon is not just circular. The moon is never circular. It's just like tilted 23 degrees. So instead of like look, instead of spinning like this, like look, it's circular. It's spinning like this, look. Like some of the moon parts are going up. Like look at the North America. Look, it just gone up, then gone down from Asia. So that's why I built a thread, and I need to measure the angle because this universe is a crazy universe with crazy laws and something. So yeah. Hey, I need to tell you something. While I was doing that, I remember something that I was doing at something that I just want to upload to you, our viewers. Miss this look. It's going to be white. Just wait. Look. You can only see this way. I need to just look this way. Oh, wait. Oh, no. Anyway. No, look. Like, look. Right here. This is the scale. And you'll say, bruh, it might be a scam. Ha 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 ha. April Fools. No, not April Fools. October Fools. But you'll say that. But for me, look at the publisher. Like, look. The publisher was in Mumbai in India, and it has even a website, and there's even an email. Like, look, it's at Mumbai. It was published at Mumbai, India, and it's checked by the National India. There's even proof. So we can just say that this is true because it's just for kids. If you want to be experts at space, like, yeah. But this is true. So I can calculate that, which is good. I just want to say something. I made Mercury. Like, just look at Mercury and Moon. They're absolutely, like, literally the same size. This was actually the same size. I did all the calculations. Right over here. This is the proof. But the explanation that I was going is that I just measure, like I just measure that, then I just put that in my real scale right there, not here. This is just later. Then it is saying 7.7, which is good because instead of just doing this again and for doing this for thread again, instead of that, we could have just used that and we can have used this. I just realized that this one, 2, 3, 4, 5, 6, 7, and this point, and this some point. I never ever realized that. Well, at least there's these two. But the only thing is, I need to find the distance. And this was my replica of my son, my mother's phone. So we can see what's a solar eclipse and lunar eclipse and a transit. Well, before that, I'll just play some thingy. I'll just explain all of the history about that and what is about solar eclipse and transit. Okay, just some short things because you won't know what is a transit. How does a solar lunar eclipse work? So yeah, so I made the Mercury gray, not that, gray, because I thought that if the color was changed, like that experiment would work. I don't know why I thought that. Well, that's okay. Well, now I need to find the accurate distance for this Earth, this Moon, and this Mercury, and this Sun. There's the floor display now. Well, let's display that short history now, yeah? Okay. Now we have known about this. So, the next thing is, do you know that the solar eclipses are getting rarer? Like 50 million years ago, the Earth was just molten lava, and the Moon was just formed by a large celestial bodies. Okay. At that time, the Moon was very close, so it can hide most of the beam of rays which has been scattered. So while it was appeared, it will just seems as the night sky. And at that same period of time, that was the last solar eclipse that has been blocked the beam of light and cast a beautiful night shadow, because after that there are some asteroids that just pull the moon, and as the moon attacked to be asteroids, it just bulges around the Earth, making it to be attractive. Attractive means it's not to be pretty, it's just to be attract, so it can be same distance. But the only problem for the moon is that the moon's gravity is weaker than the Earth. So the Earth just bulges towards the unknown of there. The unknown is this Mars, right over here. So yeah. So that's why the moon just goes away lonely and lonely. And here's a fun fact. a year, each year or per year, the moon will goes away from the earth about 1 airport size or like 4 centimeter. So this is about the solar eclipse. Then you can just represent them. Okay. Next, this is the lunar eclipse. While the sun is just going to the beam of light, it will also hide the earth. So causing like moon eclipse. That's another fun fact. A moon eclipse happens when the earth just blocks the path of light, so it cannot be reached by the moon. So it will form another eclipse called a moon eclipse. Yeah, those are real. But it can only happen at solar eclipse, but not like moon lunar eclipse, like casting a shadow of the earth turning into red. Sorry, it can't happen because the earth itself was blocked by the moon. Okay, so at lunar eclipse, there will be the sun and the earth will hit most of the parts, making a day. And this is a replica of the moon. The sum of the partial of light will just got caught by the moon and this will shine towards the earth, causing a lunar eclipse. And as we know that the distance of the source of light and the distance of the object will cast a different shadow, the different size. And as the source of light is just near to the object, it will cast a big shadow. Okay? So, this is how lunar eclipse work, and solar eclipse is just that as it's just near to the screen, only some parts will appear. Now we have finished about all the eclipse. Now we are just going to go to the Martian. What is that again? Oh, yeah. So like that, not Martian, Mercury, that eclipse. What's that again? I don't know. I forgot the name of that eclipse. Well, you might have heard later on in this video. Okay, so if there's the sun and if there's a Mercury, the Mercury is near to the sun, so it will cast a big shadow. So causing the Mercury eclipse to show a large part of the world. But the only thing is, as Mercury is near to the source of light, as humans here or anywhere in this earth experiencing that the Mercury eclipse, we'll just see a small black thing going around the sun. Yeah, not pretty amazing, but also amazing because it's rare, because it will happen 9 to 10 years in this 10 years. Okay, or 10th of a century. Okay, I mistakenly just to show this. Okay, and now that Mercury eclipse are now getting rarer because the Mercury is shrinking. It's not getting away from the sun and just glowing and going and slamming to the earth. No, that's not ever happening, and it's not just going towards the sun and just have a sun breakfast. It's not going to happen there. It's just that Mercury is just shrinking. Yeah, because of the intense heat, radiation, all of that. The Mercury is just shrinking. And it will get smaller and smaller and smaller and smaller, causing it to be not rare. It will be still rare, but it will only appear like some places. Okay, so the next is, why do we need to wear a solar eclipse glasses at the solar eclipse? Well, why not the lunar eclipse? And why do I need to wear some protection glasses for the Mercury transit? Mercury transit. Like you'll ask that. It's because that the moon doesn't moon doesn't fully now just cover that sun. That is, by the way, called total solar eclipse. It will also emit some light. That's why if you see some images, there will be like beam of light, which is UV ray, gamma ray, and everything. And if it comes to your eyes, it will damage your corona and not corona, the cone, all of that. And if you don't know a cone, it's not an ice cream cone that you're going to eat. It's not delicious. That's the cone where you can see. Where you can just see the black and white things. And the colorful cones also. And again, it's not your favorite ice cream cones. It's the cone where you can just see the most of the colors, like red, like this is yellow, this is pink, this is green, oh, this is orange, oh, this is white. Well, not technically white. Okay, so it will just damage it. And you cannot be able to see. Which will may cause an injury. Okay. Now this is how it just works. Now, if you want to have some longer explanations, I can tell you a longer explanation if you want. Okay, so if you don't want longer and if there's like time limit, you can just stick with that concept and just reform some words to technical words and you can just still. But if you want some extra information or if you just want to know about solar, lunar and transit, if you're just learning about that, I'll give you some more information. First, you will ask, why is it called solar eclipse? Can't we just call sun eclipse or Suraj eclipse or Suryan eclipse? Like, can you just call in another languages? The reason that its name is solar eclipse instead of sun eclipse. Suraj eclipse. Suraj is sun in Hindi. And all of that. It can't be called because we need the scientific terms. You know the scientific terms where there's that unknowing word, but it's absolutely important because it sees all the chemicals, compounds, all of that. You know that scientific terms. And in the solar eclipse, that's the same thing. In solar means sun, because sol means sun. It came from the Greek word. Okay, so that's why it's called solar. Okay, so that's why it's called solar eclipse. And for the lunar, why is it called lunar? Why don't we call it as moon eclipse? Why don't we call it as Chandrayan eclipse? Why are we just calling it as lunar eclipse? This is just weird. So Chandrayan is just Tamil word for moon. Tamil word. Okay. So it's just that lunar is again scientific term for moon, which is called luna, which was again came from the not the Greek word, Latin word. Yes, sun and moon were come from the Latin word. Only Uranus came from the Greek word, that only planet. So it was called Luna. And you can just tell lunar eclipse, solar eclipse, which means hiding the sun, and lunar eclipse, which means moon hiding the sun and sun hiding the moon. That's the definition of the word, but that's not technical definition. The technical definition of that particular word of solar eclipse is that the sun eclipse, and this is the moon eclipse. Okay, and what's that again? I don't know. So that's the extra information about the moon, and this is going to be the extra information about Mercury. Do you know that the sun is also expanding and expanding as the hydrogen and helium are just getting used to make plasma? If you don't know about plasma, here's a quick definition about plasma. Plasma is a matter in which heat is gone, like that. As it's getting expanded, the Martian eclipse, what am I calling Martian? I don't know. The Mercury eclipse will appear bigger and bigger, even though the Mercury will get smaller and smaller. Okay, so that's just the extra information. So bye to your geographical video and scientific video called What is a Solar and a Lunar and a Terrorist Eclipse? Bye. Yeah, so all of the setups are done now. So let's start with the transist. So you know what I said, that why is it big? It's just that you need to know absolute physics. Source of light, screen, and an object. You need 3 of those to cast an object, like a shadow. But you also know that the distance between the source of light and the distance between
the screen also depends. So if your source of light is just very near, it will cast a shadow like big. Like look, it's absolutely big because most of the light aren't spreaded. So still there is some light, like the bunch of light spreaded right there. So it makes a bigger shadow to cast. So that's why Mercury transit has like big, like spreaded one. And we still didn't talk about the rotation of the Earth. So while the Mercury is just coming to block the sun, obviously, it orbits. It doesn't orbit around the Earth. It orbits around the sun because it's a planet. So if you're trying this experiment, don't try to make orbit around the Earth. Make the orbit around the sun or the star. So you need to just rotate it so it will go. It's just a little wobbly, but if you make as a correct movement, some parts of the earth will experience this like lot. Like here that I showed that North America didn't have an appearance to show this. Okay. Okay, now I finished the Mercury transit. Okay, so next it's the solar eclipse. The amazing views of the solar eclipse. So, this is a replica of the moon. So, you know that the solar eclipse just hides the sun. Like it just hides as the sun. Well, while I was doing the solar eclipse thingy, the piece of the moon broke. So for now, I'm going to use the replica of a Mercury because like the size is just same, nearly same. Fine. Okay. So you know the solar eclipse, right? Like the amazing thing. Like it happens around about 41 percentage about this year. But it will soon get rarer. I'll explain it why, but first you need to know how a solar eclipse forms. So if the moon just comes right over there, as it's near to the screen, but farther to that the source of light. As for that, there's going to be a low. It's not going to be high like the Mercury transit. It will just appear on some layers of the earth. But we still didn't even talk about the rotation of the earth. So, if the moon just goes around the earth, then the earth also rotates. Some parts also experience of this. And even sometimes the source of light will even come at the night time. But as we need the sun for a solar eclipse, it won't happen at all of these places. Like right here I showed that South America and some parts of North America can see it, even Central America. But even though I show to that Pacific Ocean, like Australia and New Zealand, even though I show, they cannot be able to see because this part is night and this part is day. Okay. We also solar eclipses are rarer because as the earth is just bulges and pushed toward Yeah, because of gravity. Like the moon also bulges, but the earth also shrinks at that time. The moon will just get thrown away. Yes, like it's just a comparison. Like in 1 year, it can just fit an airport. Like the length will change about like the airport size or 4 centimeter per year. So soon solar eclipse will be rarer, but annual eclipse will be absolutely often. Like it will be common, and solar eclipse will be rare. You can see this in Minutepyscics, like there, right there. But as the moon gets near to the sun, it can only appear as the annual eclipse, where the moon won't fully block the sun. It will just block like the partial amount of the sun. Oh yeah. Also, just remember that while the solar eclipse is beginning, you'll notice that when the moon just hides from the sun, the sky won't turn blackish night. It's because of the moon won't fully just block this. Like there will be some still areas, like you can see in this part, this ray of light can pass through it. Like just wait, look. Some parts of that area can be passed through it. So that's why you won't get a night experience of that. As we know, first the moon's just thrown away and being a planet, and the second is just that you won't see night. Yeah, about 50 billion years ago, when Earth doesn't even have life, the moon was very close. So when it came to here, it was just very large. Like it wasn't very large like the Mercury transit, and not very common to whole area, even it's rare. It's not like that. It was just so close, and it will appear in some places, but it's common. No. But after 5 billion years ago and another 5 billion years ago, again, it will come too far that it will be rare, but you can see from many places, like as the Mercury transit. Okay, so that's why you cannot see the nights and stars. Only about 50 billion years ago, well, that was the final one, that the moon just covered the sun and it was night pitch dark with blazing stars. Okay, so now we have seen the solar eclipse. Okay, so now we are going to see how the lunar eclipse work. So we know that lunar eclipse just go back of the sun, and you will say, how does this spread like all over there? Like that was my same question at that time. Like if you can just see that there's some glaring light right there. There's some sunshine. Now, even though the earth just absorbs most of the source of light, the moon will still absorb some of the source of light, reflecting into here and just glowing right there. And as we know that if there's a source of light which is near to the screen, but still the object is the source of light, it's just absolutely near. So that's why it just covers the most part of the globe. And still we haven't even seen how while the earth rotates. So while it comes, some of the glarings will come and the earth will rotate and it will go. So yeah, this is how lunar eclipse work. But still, just remember that a lunar eclipse is more common than a solar eclipse, because a lunar eclipse is just that we need to be just near to the earth. But as the earth bulges into the sun, but not mostly not facing the sun, there will be more like a lunar eclipse than solar eclipse. So, a lunar eclipse will appear about each 5 years in a place, about 2 to 5 years in a place to have a lunar eclipse. But a solar eclipse is just about now 10 to 11 years. From this year to about maximum 10 years after that. But after that it will just change and vary away. And it will be in lower accuracy. And the Mars transit that we have explained right there, right? The Mars is not going to just go into the sun, it will just shrink in size. Which means it will still be rare, because you can see the Mercury that eclipse as it will take about 9 to 10 years. Yeah, the transit. So yeah, that's how much rarity it will come. But still, even though this 9 to 10 years of repeating on that same place, even though for that it will just shrink and it will be lower, and more places won't see that much, so it will just getting shrinker. So it will just getting small and small and small. But after a century, it will just smallen about 3 or 4 centimeters. So yeah, that's all.
Okay, so also when I was recording all of that eclipse and transit, it was just 11 o'clock. I'll just upload some websites that you can research about that. Okay, bye. Please help me, I'm a